Next is question number 76, which says that if theta and pi by 2 minus theta are the eccentric angles of the extremity of a focal chord of the ellipse x square upon a square plus y square upon b square equal to 1, then the eccentricity E of the ellipse may be. Now, for 2 points to be given, we know the equation of, firstly, let us plot the ellipse. Let us say we have 2 points here, that is theta and phi. Then the equation of this chord can be written as x by a into cos of theta plus phi by 2 plus y by b into sine of theta plus phi by 2 will be equal to cos of theta minus phi by 2. Now here the 2 points that are given are theta and pi by 2 minus theta. That is, the value of phi can be substituted equal to pi by 2 minus theta. So from here we will get x by a into cos of theta plus pi by 2 minus theta, that is pi by 4. That is, cos pi by 4 is 1 by root 2. Similarly, here also we will get y upon root 2 into b is equal to cos of theta minus pi by 4. Now, as it has been given to be a focal chord, so it will be passing through either plus AE comma 0 or minus AE comma 0. So let us put it here. We will get this term will be equal to 0. So we will get plus minus AE upon root 2 into A. This will be equal to cos of A minus B is equal to cos A cos B plus sin A sin B. So this will be equal to cos theta plus sin theta upon root 2. Now these two will get cancelled and A can also be cancelled. So this will be equal to E is equal to plus minus cos theta plus sin theta. We have got two values of eccentricity. Now from the given options, only option 2 is the correct answer. Next is question number 77, which says that Harish plays 4 matches with Ravi. The probability of Harish winning a match is 3 by 5 and losing a match is 2 by 5. The probability of Harish winning second time in 4th match is, let us say he have played 4 matches. Then in this match, Harish should win by probability 3 by 5, and from these 3 I will select any one match by 3C1 ways. I have selected any one match from these 3 and Harish will win in that one by 3 by 5 probability, and in the other 2 that are left, Harish will lose by probability of 2 by 5. Now this can be written equal to 27 into 4 upon 625. So that is equal to 108 upon 625. So we can see that option number 2 is the correct answer. Next is question number 78, which says that if A is a square matrix of order 3 and determinant of A is equal to 2, then determinant of A into adjoint of adjoint A is equal to. Now, determinant of determinant A into adjoint of adjoint A determinant. This is equal to, if I take determinant A out from it, it will be equal to determinant A whole raised to the power 3. That is the order of the matrix into determinant of adjoint A. Now this is equal to determinant A cube into determinant of determinant adjoint A is equal to adjoint A determinant raised to the power n minus 1. N here is 3, so it will be equal to 2. This is equal to determinant A cube into adjoint A determinant will be equal to determinant A raised to the power n minus 1. That is again 2 into 2. That is 4. So this is equal to determinant A raised to the power 7. That is equal to determinant A is equal to 2. So this is equal to 2 raised to the power 7. So the correct answer is option number 1. Next is question number 79, which says that the equation of the locus of the midpoints of the chord of the ellipse x square upon a square plus y square upon b square equal to 1, which passes through the center of the conic xy minus x minus 2y equal to 0 is. Firstly, let us find the center of the conic xy minus x minus 2y equal to 0. That is x into y minus 1 minus 2y. Let us add and subtract 2 from here. So this will be equal to x into y minus 1 minus 2 taking common, y minus 1 equal to 2. That is y minus 1 into x minus 2 equal to 2. So the center of the conic is 2, 1. Now we have to find the equation of the locus of midpoints of the chord which passes through the center. Now let us say the midpoint is x1, y1. This is the midpoint. So we know the equation of chord if midpoint is given, that is t equal to s1. So it can be written as x into x1 upon a square plus y into y1 upon b square, cancelling 1 on both sides. It will be equal to x1 square upon a square plus y1 square upon b square. As this chord is passing through the point 2, 1, let us substitute it here. That is 2 into x1 upon a square plus 1 into y1 upon b square is equal to x1 square upon a square plus y1 square upon b square. As we have to find its locus, so x1 and y1 can be replaced by x and y respectively. And multiplying the equation by a square into b square, we will get 2x b square plus a square y equal to b square x square plus a square y square. So this is the locus that we get from here. That is, the correct answer is option number 4. Next is question number 80, which says that if A, B, C are 3 sets such that A and set C have m common elements and number of elements in set B is n. Number of common elements in set A cross B cross C and C cross B cross A is a unique question from the chapter sets. Let us discuss it. Let us say the common element is x, y, z. Now, to find the number of common elements in set this and this, x should belong to set A and x should belong to set C, right? And similarly, z should belong to set A and z should also belong to set C, and y simply belongs to set B. Now, it is given that this element should belong to both set A and C. Now, number of common elements in set A and C are given to be equal to m. Therefore, x can take m values. Similarly, if I talk about y can take n values, that is number of elements in set B. It can take n values. Similarly, z can take m values, that is, z should belong to A intersection C. That is, number of common elements in the both sets are m square n. That is, the correct answer is option number 1.